Hi, welcome to the lecture number 3.1. In this lecture, I will teach you about system clocks configuration. So, let's get started. After finishing this lecture, you will be able to configure the system clocks using external crystal, and then set the sysclock frequency to the maximum value, and also use the HAL microvision debugger to debug the STM32. Here, I will show you the reference manual of the STM32 microcontroller. This is for STM32 F101, 2, 3, 5, and 7 series. You can download this document from st.com. This reference manual contains all of the information about STM32 peripherals. So, if you want to know more about STM32 peripherals, you can read this document. In this lecture, I will show you about the clock configuration. So, you can go to chapter 7, go to clocks. Here you can see the clock tree diagram for this microcontroller. There are two main clock sources that can be used to drive the system clocks: 8 MHz high-speed internal RC oscillator, and then the 4 to 16 MHz high-speed external oscillator. Both the high-speed internal or the high-speed external can be connected to the system clock directly or through the PLL to multiply the clock value, so you can get a more higher clock speed. There are also two secondary clock sources: the low-speed internal RC, which is 40 kHz, and then low-speed external oscillator, which is 32 kHz. The LSI can be used to drive the independent watchdog and also the RTC, while the LSE can be used only to drive the RTC. The sysclock is used to drive the ASB bus, the Cortex M3 processor core, memory, and DMA, and also the Cortex 60 timer, and then the APB1 peripherals, and then the APB2 peripherals, and there are also other peripheral clocks. Okay, in this demo, I will show you how to configure the system clock using high-speed external oscillator and set the frequency to the maximum value. First, you have to enable the system debug peripheral, and then if you go to clock configuration tab, here you can see the clock tree diagram like we saw before in the reference manual. By default, the high-speed external option is disabled. To enable this, you have to enable the external crystal pin in pinout configuration. You can go to pinout and then select RCC, and then you can enable this pin. These two pins will be used to connect to the crystal oscillator. Here in the clock configuration tab, you can set the external crystal value. In my board, the external crystal value is 8 MHz. After that, you can set the S-clock frequency to the maximum value, which is 72 MHz for this microcontroller, and then press enter. The CubeMX will automatically calculate the required PLL value and the prescaler value in order to achieve the 72 MHz clock. The result is high-speed external oscillator is selected, and the prescaler is 1. After that, the 8 MHz clock will be multiplied by 9 in order to achieve 72 MHz. The ASB bus clock, core clock, memory, and DMA is 72 MHz. System timer is also 72, and peak clock 1 is 36 MHz. Peak clock 2 is 72 MHz. In configuration tab, you don't have to change anything, and then after that, you can generate the code. Here in the main.c file, there's a function called system clock config. This function is generated by CubeMX to configure the system clock. Let me explain how this function works. There is two structs that will be used to initialize the RCC, one for oscillator and one for the clock. The function of this line is to select the oscillator that you want to initialize, which is the high-speed external, and then you have to turn on the high-speed external oscillator, and then select the prescaler to 1. These three line of codes is correspond to step 1, 2, and 3 in the clock tree diagram. This is for select which oscillator that we want to initialize, which is the high-speed external, and then turn on the high-speed external oscillator, and then after that select the prescaler to 1. The function of this line is to turn on the PLL, and then after that select the high-speed external oscillator as the PLL source, and then set the PLL multiplier to 9. These three line of codes is correspond to step 4, 5, and 6. In step 4, you turn on the PLL, and then select the high-speed external oscillator as the PLL source, and then select the PLL multiplier to 9. This line of code is used to initialize the H clock, sys clock, P clock 1, and P clock 2. In this line, the sys clock source is selected from the PLL clock, and then the ASB divider is set to 1, the APB1 divider is set to 2, and the APB2 divider is set to 1. These 5 line of codes is correspond to step 7 until 11. In this step, you can select which clock that you want to initialize, which is sys clock, H clock, P clock 1, and P clock 2. After that, you can select the sys clock source, which is from PLL clock. After that, you can set the ASB prescaler, which is 1, and then set the APB1 prescaler, which is 2, and then set the APB2 prescaler, which is 1. The last thing is you need to configure the flash latency. You can go to chapter 3 and then select memory map and select embedded flash memory and go to reading the flash memory. Here you can see if the sys clock value is between 48 MHz and 72 MHz, then the flash latency must be set to 2 wait states, which is correspond to these settings. This part of the codes is for configuring the SysTick timer, which I have explained it in the previous lecture. To verify whether the sys clock has been set to 72 MHz or not, you can use the KL Microvision Debugger. Here I add 2 lines of codes to get the current sys clock frequency and save the value in a variable called sys clock. After you program the STM32, you can go to debug and start debug session. By using the debugger, you can execute your code line by line. Here, you can press this button or press F10 to executing one function without entering it. You can see the control is moved from this line to this line. So this line of code has been executed. By using debugger, you can monitor the value of processor register. You can also see the value of peripheral register. For example, you can see RCC. Here you can see the RCC register and its value, and you also can see the value of variables. For example, I will monitor the value of sys clock variable. If this window is not shown, you can click this button, watch window. Then you can enter your variable name, which is sys clock. And then you can continue to execute the codes by pressing this button. Here you can see the variable is updated. The sysclock value is 8 MHz. This condition happens because every startup, the default sysclock is high-speed internal oscillator, which is 8 MHz. And then after you execute several lines of code, the sysclock value is changed to 72 MHz as expected. Okay, this is the end of this lecture. In this lecture, we have learned how to configure the sysclock using high-speed external oscillator and then set the value to maximum value. You also learned how to use scale microvision debugger to debug your code. Thank you for watching and see you in the next lecture. Goodbye.